morning, guys. So today what we worked with in class was we started looking into Euler circuits, right? Euler circuits. And again, there are two different things, right? There's Euler circuits, and then there's something else called Euler paths, right? Euler circuits and Euler paths. So what we know about an Euler circuit is an Euler circuit. First, let me show you what it looks like, just so you guys have an understanding of it. When it comes to an Euler circuit, it would look something, let's say we had that, right? Where we had these vertices right there, right? Let's give you something like that. Right? And so what an Euler circuit is basically you have a graph where, let's say our starting point is here, right? This is where we're starting, right there. Euler circuit basically tells you that basically you can recreate this figure, right? Where you never repeat any edges and you're finishing where you started. So basically think of it as a tracing game, right? Where you're picking a starting point, you're trying to make sure that you trace all of the edges, and then for it to be a circuit, you finish where you started, right? So if I'm starting here, again, just to create that exact picture, we would go this way, right? Because it does that. Go this way, go this way, go that way, and then we finish it, right? We basically recreated everything we had, and we started where we finished, right? We finished where we started. Whenever you have that, right? Basically, whenever you're able to draw every edge just once, and you cannot trace an edge, you can never trace any of the edges. Whenever you use each edge only once, and you finish where you started, that's a circuit, right? A circuit, most important thing, it ends where it began. That's what we have to keep in mind. An Euler circuit, it ends where it began. And again, it's the whole idea of tracing the edges. So Euler circuits and Euler paths, it's all about the edges, right? When it comes to an Euler path, let me show you here. Euler path would be something, let's say, like this, right? And I'll show you why this would be an Euler path. Where we have this idea, right? Where for it to be an Euler path, again, you have to always pick a starting point, right? It doesn't matter where. But let's say I were to pick this starting point right there, right? And again, you want to go over every single edge once. You can't ever retrace. And if I start here, again, pick right there, go that way, and then go this way, and then go this way, go this way, and then you have to, again, go down because you got to make sure you cover every edge. But now, that's the thing about an Euler path. An Euler path, we've traced every single edge, but now it's impossible to get back where we started. And whenever it's impossible to get back where we started from, because now if I stopped here and then I went back this way to come here, I can't do that, because now I'm going back on this. I'd be tracing back. Can't do that, right? So if we end somewhere different where we started, because we started here, right? We started there and we ended here. If we end where we didn't start, that's what a path is, right? Basically, an Euler path does not end where it started. That's the biggest difference. And again, I just wanted to show you guys this because Euler paths we're going to be working with next time. Today we're just going to be working with Euler circuits, guys. But again, just remember, in terms of a circuit always ends where it began. So if you start here, you have to trace everything once. You have to go over every edge and then finish where you started. An Euler path, where you start isn't exactly where you end. So if you end at a different place than where you started, that's an Euler path. As long as you go over every single edge, you know what I mean? So again, today we're only working with just Euler circuits, right? And again, I want to focus back on this because sometimes some people think, oh, I need to trace this, can I see it, can I not see it? The good thing about these problems is there is a mathematical way to actually always figure this out without having to count, right? So let's say I were to go back to this, because the is always trying to figure out, is it possible? Can I actually do this, right? And again, it's a lot easier to always be able to figure out whether you can do this before you even start, right? So let's call this A, let's call this C, let's call that F, let's call that H, let's call that L, right? In order to figure out whether it's an Euler circuit or not an Euler circuit, what you have to do is first figure out all the degrees of every single vertex, right? Which you guys remember how to do, right? So if I want to figure out the degree of A, we see how many edges actually is coming from A, right? So A goes 1, 2. So the degree of A would be 2. For C, again, we see 1, 2. For F, 1, 2. For H, 1, 2. For L, 1, 2. And so we notice something, and this is the most important thing whenever it comes to an Euler circuit. All of these numbers, you're gonna be hearing something again, which you did today in class, which are called odd number degrees and even number degrees, right? You have odd number degrees, and even number degrees, And again, the one thing you gotta make sure you know, odd numbers are the numbers like 1, 3, 5, 7, 9, all of that, right? 1, 3, 5, 7, 9. Those are odd numbers, right? Even numbers are 2, 4, 6, 8, and so on, right? Those are even numbers. So when they're talking about odd number degrees, that's how we figure out whether something is an Euler circuit or not, right? Because for something to be an Euler circuit, it cannot have any odd number degrees. There can be no odd number degrees. So whenever we're trying to figure out whether it's an Euler circuit, the way you always tell is you look at it. If all of these are even, right? Because 2 is even, 2 is even, 2, 2, 2, they're all even. That means there are no odd number degrees, right? No odd number degrees. And if you have 0 odd number degrees, it's an Euler circuit, right? It would be a circuit. If there's 1 or 2, if there's any, then it's not going to be. You know what I mean? Literally, an Euler circuit, it can have no odd number degrees. It has to have 0. Second there's 1, that's it. It's no longer an Euler circuit, right? And again, it's the easiest way to figure this out, right? But again, I'll do 2 more of practice just to be able to show you guys this. Because it is just the whole point of getting in the habit of it and being comfortable with it as well. So let's say now that I had something that looked like, let's say I had that, right? We have this, we have that, we have that, we have this, right? And let's say I wanted to figure out whether this is an Euler circuit or not. Remember, whenever you want to figure out if it's an Euler circuit, you have to check the numbers of degrees first, right? So from this point, that has a degree of 1. This one here has 1, 2, 3. This one has 2. This one has 2. So automatically, when we see this, again, that's an even number, that's an even number, but that's an odd and that's an odd. So the second you see one odd number degree, which it has more than 1, it has 2, since that has odd number degrees, this we automatically know it's not an Euler circuit, right? It's not an Euler circuit. And it's not an Euler circuit because, again, it has odd number degrees. We cannot have any odd number degrees, right? So it's just getting in the habit of seeing that, right? Let me do another one just for you guys to actually be able to see it more. Let's say we had this, right? We have that right there, right? We have that. Let's say I were to look at this, right? And I wanted to figure out if this is an Euler circuit or not, right? So, again, just analyze what we have, right, to figure out, and always figure out the degrees of every single one. Over here, we see that this is 1, 2, right? That's 2. We know that this is 1, 2. This one over here is 1, 2, 3, 4. This one is 1, 2. This one is 1, 2. So now we look at it. Again, are there any odd number degrees? So 2 is even number, 2 is even number, 2 and 2 are even number, 4 is an even number, right? They're all even numbers. So if they're all even numbers, automatically we know it's in Euler circuit, right? It's in Euler circuit because they're all odd number degrees. And again, it's one of those things you can actually check just to make sure that it actually works. Let's say I had any starting point that I wanted to, right? Pick anyone. Let's say I pick this point right here. Say I want to start right there. There we go. We go this way. We go up. Again, we go back there. We go this way. We go down. We come this way. And we did it. We literally did everything. We traced every single edge and we finished where we started. Definition of an Euler circuit. It's just so much easier though with the numbers, guys. And I want to do one more just to make sure you guys actually see it. And again, it's all good practice, guys. It's all very good practice. Let's say that I had this one that looked like this, right? Let's say that I had that, right? And again, it's no different, but it's just trying to analyze whether it is an Euler circuit, whether it's not, right? We have a bunch right there, right? And just do the same thing you've been doing before, right? Just figure out what the degrees are. So we know that the top one is 1, 2, right? We know that this one here is 1, 2, 3, 4. We know that this one here, 1, 2, 3, 4. We know that this one here is 1, 2. We know that this one here is 1, 2. And we know that this one is 1, 2, 3, 4. So even though it looks complicated, we automatically know again, it's an Euler circuit. Right? It's an Euler circuit because again, if all of these numbers, all of these degrees, they're all even numbers. If there's no even number, it's not an Euler circuit. If there's any odd number, if there's any odd number, then it's not an Euler circuit. If there's no odd numbers, it's an Euler circuit. And if you wanted to actually check it out, again, pick a starting point. We can start here, go there, right? Start here, go this way, right? Let's say then I go this way right there, right? Go this way, go down, go this way, go that way, come this way, and then finish it up. Right where I started, and I traced everything. Every single one. It's all done. I never lifted up my pen, because again, that. Finish where I started. That's why it's an Euler circuit. So always remember, guys, if it has an odd number degree, it's not an Euler circuit. If it has all even, it's an Euler circuit. Take care.